I equal to 0 to infinity minus a whole power I into x power I. So like this we can write. So if it is 1 plus ax whole power minus 1, so it is 1 minus ax whole power minus 1, this can be written as sigma equal to 0 to infinity ai into x power I. Some, if it is 1 plus ax whole power I whole power minus 1, this can be written as sigma equal to 0 to infinity minus a whole power I into x power I. Same thing, 1 plus x whole power minus 1 also can be written as sigma equal to 0 to infinity minus 1 whole power I into x power I. So these two are the, if these two are their things. So okay, up to this one, okay, we will be having a minus value. So if it is minus n, if it is a finite series, minus n is there. If it is a finite series, so what will be the answer? What will be the generating function? How can you write the generating function if for the finite series? If it is, these two are the infinite series. These two are infinite series, that is minus 1. So that means that we will be having a infinite values. So we can't count. So we don't know the values. So it is infinite series. So we will be moving to the finite series. See here, it is the finite series we will be having. So that is, we know the n value. So till n the values are going to be taken. Till n only the values are going to be taken. So this can be written as 1 plus x whole power minus n. 1 plus x whole power minus n can be written as sigma I equal to 0 to infinity minus n ci into x power I. Minus n ci into x power I. So minus n ci can be written as n plus r minus 1 cr into x power r. So n minus n plus r c r, that can be written as n plus r minus ncr can be written as ncr can be written as n plus r minus 1 n plus r minus 1 cr minus ncr. If it is a minus value, if it is a non-positive value is there in the combinations, so that can be written as minus n plus r minus 1 cr. So that is then into x power r into x power r. So if it is a r value, so that can be written as, so the generating function for the finite series of 1 plus x whole power minus n can be written as sigma I equal to 0 to infinity minus n ci into x power I, minus nci into x power I, or we can say minus ncr into x power r. So minus ncr can be written as n plus r minus 1 cr into x power r. So like that. So same thing, 1 minus x whole power minus I, 1 power x whole power minus I. So this can be seen here, it is there. So minus 1, it is 1 plus x, so it is sigma equal to 0 to infinity minus 1 whole power I into n plus I minus 1 ci into x power I. So what I said, that the same thing. So n plus r minus 1 cr into x power r. So minus 1 whole power r, because here the plus is there. So the same thing here, the minus is there. Then we won't get this minus I minus 1 whole power I term here. That is simply we can write sigma equal to 0 to infinity n plus r minus 1 cr into x power r, n plus 1 r cr into x power r. So directly we'll get. So this is the difference between the finite series and the infinite series. So if it is an infinite series, so if the infinite series, this is the negative values are there also. If the infinite series, directly we can write sigma equal to 0 to infinity x power I, or sigma x power r into n power r. So 1 minus x whole power minus 1 minus x whole power minus I can be written, minus 1 can be written as sigma equal to 0 to r equal to 0 to infinity x power r, and 1 plus 1 minus ax whole power minus 1 can be written as can be written as sigma r equal to 0 to infinity minus a whole power r into x power r, and if it is minus, then we will not have this minus term. So sigma a power r into x power r directly we can write. So say these things are going to be implemented. Sigma, if it is a finite series, sigma equal to 0 to infinity minus ncr into x power r, and if it is minus, if it is 1 minus x whole power minus n, sigma equal to 0 to infinity minus ncr into x power r, or 1 plus x sigma I equal to 0 to infinity, sigma I equal to 0 to infinity minus x minus 1 whole power r into minus ncr into x power r. So these are the things will be having. These are the formulas you are going to be used in the things. So coming to the next one. So these things we discussed in the last class, that is how you are going to find the generating functions for the following sequences. So these sequences we have done, and simply we compared with the each whatever the sequence has been given, whether it is the infinite series or finite series. We'll be checking. If it is infinite series, then we'll be using a of x equal to a1x plus a0 plus a1x plus a2x square plus a3x cube, and so on like that. Then if we can able to write that one into the closed form series, then we'll be writing. Otherwise, we'll be keeping the sequence as it is. So here we'll be having 1 plus 2x plus 3x square plus 4x cube and so on. So this can be written as 1 minus x whole power minus 2. So 1 minus x whole power minus 2. It is infinite series, so that can be written as 1 minus x whole power minus 2 if the in the form of 1 plus 2x plus 3x square minus 4x plus 4x cube and all. So coming to the second series is there 1 minus 2x plus 3x square minus 4x cube and so on. This can be written as 1 plus x whole power minus 2. That can be written as 1 plus x whole power minus 2. So like that we will be converting the given sequences. That will be that like this we will be converting the given sequences into the generating function, and from the generating function we will be getting a closed form equations also. From the generating functions we will be getting the closed form equations also. So then okay, if till this one we will be converting the sequences have been given, then we will be converting the sequences into the generating functions, and from the generating functions we will be converting those things into the closed form equations. So now here we will be doing the reverse things. So they will be given the closed form sequences, then closed form equations. From the closed form equations we have to find the sequences. So how we can able to find this one? Simply same thing. So whatever the closed form equation has been given, that is going to be done in the that we have first we are going to find out the generating function for that one. Then whatever the whatever the what to say sorry a0 a1 a2 values are coming. So those things, whatever the coefficients are coming for the x power 0, x power 1, x power 2, x power 3, x power 4, and so on, those coefficients are going to be kept aside. Those things are going to be called as a sequence. Those things are going to be kept aside, and those things are going to be called as a sequence. So now we'll be having 2 plus x whole cube. So now we'll be having the 8 plus x cube plus 12x plus 6x square. So this can be written in the form of x power 0, x power 1, x power 2, x power 3. In this form we'll be writing first, then it is going to be converted into x, that is x 8 into x power 0 plus 12 into x power 1 plus 6 into x square plus 1 into x cube. So then later we'll be having a 0 into x power 4 plus 0 into x power 5 plus 0 into x power 6. Like that we'll be having. So that can be the sequence can be written as 8, 12, 6, 1, 0, 0, 0. So like that the sequence will be coming. So next thing, so 2x square into 1 minus x whole power minus 1. So we know that 1 minus x whole power minus 1 can be written as 1 plus x square plus x cube plus x power dash dash. So like that, then that is going to be multiplied with the 2x square. So we'll be getting 2x square plus 2x cube plus 2x power 4 plus 2x power 5 and so on. So here we'll not having the x power 0 term and x power 1 term. So we'll be writing those places as 0. So the sequence is going to become 0, 0, 2, 2, 2, and so on like that. So that is the sequence for the closed form equations. Also we'll be converting the given closed form equation into these sequences. Then the 3x cube plus e power 2x. So here the same thing is there, e power x can be written as 1 by 1 plus x by 1 factorial plus x square by 2 factorial. So in the place of x we'll be having the 2x. So same thing we'll be keeping, and we'll be getting the things 1, 2, 2, 26 by 6. So like that the given closed form equation also can be converted into the sequence by using the generating functions. So for all these things we required is we should know for what equation what will be the series and what will be the equations will be coming. So those things we should know. So next, so these are all things we did in this. So next thing, so the calculating the coefficient of generating functions. So till now we have whatever the sequence has been given, that one has been converted into the generating function, and further generating function we have seen and we have done with the closed form equations, and then the closed form equations from the sequence we have done with the generating functions, and from the generating functions we have done with the sequences. So vice versa we have done from series sequences to generating functions and closed form equations, from the closed form equations generating functions and sequences, vice versa we have done. Now the thing is that we are going to be calculating the coefficient of generating functions. So what is the coefficient of a generating function? So now we are going to be calculating the coefficient of a generating function. Before that one, we all know that one, if n is a non-positive integer, if n is a non-positive integer, then minus n cr equal to minus 1 whole power r into n plus r minus 1 cr, n plus r minus 1 cr. So it depends upon the r value we will be having, the whether it is a positive or negative will be getting. So same thing what I have explained you in the sequences, in the closed form equations I have shown you that 1 plus x whole power minus n, then written as sigma r equal to 0 to n, sigma r equal to 0 to n, then 0 to n minus 1 whole power r into a power r into x power r. So like that we have done the things. So same thing, 1 minus x whole power minus n, sigma r equal to 0 to n will be having 0 to n will be having what is that, a power r into x power r. So like that the things we have shown, and then those things are going to be used in the finding out the or calculating the coefficient of a generating functions. Those things are going to be used. These two things, these formulas are going to be used when you are going to be calculating the coefficient of a generating function. So coming to the calculation of the coefficient of a generating function, so what are the things that are there in the sense here, I will explain the reverse now first. So what are the sequence that is there, then we come in reverse, we can understand easily. So first you are going to find out f of x. So what is an f of x in the sense, f of x is nothing but f1 of x into f2 of x into f3 of x and so on fn of x. So the f of x is a function. So that is a function, or that is the function which you are going to be calculated. F of x is going to be calculated with f1 of x into f2 of x into f3 of x and so on f1 of x. So from this one we have to find out the x power r. From this one we have to find out the x power r, and for the x power r the coefficient has to be find out. Whatever the x power r is there, for that x power r we have to finding out the coefficient. That is our problem. So how you are going to be calculating this coefficient in the sense, so to determine the number of integer solutions, to determine the to determine the number of integer solutions of the equation e1 plus e2 plus e3 and so on en equal to r. So I said you that we are going to finding out the coefficient of x power r, that is the r value we know, so that is the r. So what is that r value in the sense, e1 plus e2 plus e3 and so on n. What is that n now? We are having, we know that one, n is nothing but the f1 of x. F of x is nothing but f1 of x into f2 of x into f3 of x into and so on fn of x. So that n equal to this en. So whatever the value n is there in the fn of x, that n equal to en. That is nothing but, that is 1 plus x whole power n, like that will be having 1 plus x plus x square or x cube and so on whole power n. So that n value you are going to be considering here n. So e1 plus e2 plus e3 and so on n equal to r, where 0 is less than or equal to r is less than or equal to n, under the constraints that e1 can take the integer values of a11, a12, a13, a14 and so on. Then e2 can be take the integer values of a21, a22, a23, a24 and so on. En can take the values of an1, an2, an3 and so on. So to solve this problem, first define the functions f1 of x, f2 of x, f3 of x. So how you are going to be defining? I said you that we'll be having the f of x can be done by f1 of x into f2x into f3x and so on. So now we are going to be finding out what is that f of x, that is f1 of x and f2 of x and f3 of x is nothing but, we are going to be finding out that f1 of x equal to x power a11 plus x power a12 plus x power a13 and so on. f2 of x equal to x power a21 plus x power a22 plus x power a23 and so on. So like that fn of x equal to x power an1 plus x power an2 plus x power an3, like that will be finding out. So now this is so we said that one. So whatever the x power r, that r equal to e1 plus e2 plus e3 and so on en equal to r we said. So now what is this e1 comma e2 comma e3 and so on in the sense. So whatever the value of r is there, so that is, suppose so if you solve the problem you can understand easily. So here this e1, e2, e3 and so on en, the number of n, so the value, how many, what is the value of n is there, that many number of ens will be there here. So see here now, So to find the coefficient of x power 9 comma x power 25 in x1 plus x cube plus x power 8 whole power 10. See, this is the problem given for us. We have to find the coefficient of x power 9 in the equation 1 plus in the expansion of 1 plus x cube plus x power 8. So how many? What is the coefficient of x power 9? So we'll be having a lot of things here. So that means that x power 0 plus x power 3 plus x power 8. So here the coefficient of x power 9, we said that one we are going to find out the x power r, the coefficient of x power r, that is this r equal to 9 here, the coefficient of x power 9. So x power r is nothing but, so that is r equal to 9. This is the r equal to 9 here we are having. So this is r, this is the r equal to 9 first, right? So what is the n value? So this is the n value. So we said that 1 plus x plus y whole power n. So whatever the thing that is n. So that means that now it is going to become, so e1 plus e2 plus e3 and so on, e10 equal to r, that equal to 9. So e1 plus e2 and so on, e10 up to e10 will be having, so up to e10 that equal to 9. So next, so now we are going to find out what all the E0, EI values are there. So what all the things are there here? We'll be having the x power 0, comma, we'll be having the x cube, comma, we'll be having the x power 8. These are the things we are having. So these three things are there, that is 0, comma, 3, comma, 8. So by using these three, how many number of times you are going to use these three values to get the value 9, that you are going to be find out. That is going to be called under the constraint solutions, under the constraint repetitions. So you are going to repeat the values to get the what is that, coefficient of 9. So how many number of times you are going to repeat these values to get the 9. So how many number of times you are going to use these three values to get the 9? Generally just you think on this. So I am having the values 0, comma, 3, comma, 8. So by using these three values, I have to get the 9. So how many number of times I am going to use the values? I am going to use 3 into 3 times. So this is 3 into 3 times. So I am going to get the 9. So 3 into 3, 3 plus 3 plus 3, I am going to get the 9. And I can't use 8. So because that is not, if I am going to add 8 plus 0, 8 only coming. If I am going to 8 plus 3, that is going to be 11, that is greater than 9. So I am going to use 8 into 8 plus 8, 16, that is also greater than 9. So I can't use the 8. So 8 is going to be used 0 factorial times. So I can write here. So 3 equal to 3 times I am going to use. So how many number of things are there total here we are having? So 10 things are there. So I can use the 0 7 times. I can use the 0 7 times. So 8 I can't use. I'm going to use the 8 0 fact 0. So I don't, that is not considerable. So that is 0, not using 8. So that is not considerable. So here this is by using the constraint repetitions, n factorial by q1 factorial into q2 factorial. So here we'll be having the 10 factorial by 3 factorial into 7 factorial. 3 factorial into 7 factorial. So same problem, next in the same problem, this one. In this one we'll be having, we have to find out the x power 25, the coefficient of x power 25. Then we'll be having the r equal to 25. So by using this 0, 3, 8, we have to get the 25. See how you are going to get this 25? Just you think yourself first. So we can use 3 times, that is 9, plus here I am going to use the 8 2 times, that is 16. So already 5 completed. So I am going to use 3 plus 2 5. Then I am going to use the 0 5 times. So that is 3 is going to be used for 3 times. 8 is going to be used for 2 times. Then 0 for 5 times. So this can be written as 10 factorial by 3 factorial into 2 factorial into 5 factorial. And this is the constraint repetitions, because we are going to have the constraint, we are going to be done in the constraints. Where what are the constraints are there? By using the 0, 3, 8, we have to get the value of 25. How many number of times you are going to use? So because on n equal to 10, r equal to 25, and the constraints are 0, 3, 8. So here r equal to 9 and n equal to 10, the constraints are same 0, 3, 8. So the coefficient is going to be done by n factorial by n factorial by q1 factorial to q2 factorial. So that is 10 factorial by 3 factorial into 7 factorial. Coming here, 10 factorial by 3 factorial into 2 factorial into 5 factorial. Just to have a glance on it for 2 seconds. Then we'll move to the next problem. Here we are not using the 8, we will be using only 3 comma zeros. So 3 is going to be used for 3 times and 0 is going to be used for 7 times. So we can write this as 10 factorial by 3 factorial into 7 factorial. So coming here, in this one, for getting the 25, we will be using the 3 times, 2 for 2, 8 for 2 times and 0 for 5 times. So that can be written as 10 factorial by 3 factorial into 2 factorial into 5 factorial. So next thing is find the coefficient of x power 32 in 1 plus x power 5 plus x power 9 whole power 10. It's the same problem. Here n equal to 10. Here we are having n equal to 10 and r equal to 32, x power r equal to 32. So n equal to 10. So we'll be getting the 10 values e1 plus e2 plus e3 and so on. E10 equal to 32. And what all the values are there for us? Constraints are there 0, 5, 9. So by using 0, 5, 9, we have to get the value of 32. We have to get the value of 32. So how many number of times you are going to repeat these values 0, 5, 9 to get the 32, and the constraint is the maximum number of repetitions should be my maximum number of repetitions are equal to 10 because n equal to 10. So now we are just using. So first 5 only one time I'm going to use, and the 9 plus 9 plus 9 27 plus 5 32 I'm getting. So I'm going to use the 5 one time and 9 three times, and then the rest of all the things I'm going to use the 0. Uh, that is how many number of times? 6 times I'm going to use the 0. So we'll be having 10 factorial by 1 factorial into 3 factorial into 6 factorial. 1 factorial by 3 factorial, 10 factorial by 1 factorial into 3 factorial into 6 factorial. This is the constant repetitions. If you have a glance on it. So r equal to 32, n equal to 10, r equal to 32 and n equal to 10. So we will be having the values for getting the n equal to 32. For the r equal to 32, we will be getting the 10 factorial by 1 factorial into 3 factorial into 2 factorial, 6 factorial. Next one, the next problem. So we have done the finding the coefficients. So we'll be equating the x power r value, x power whatever the coefficient if we want to find out, that is r. We said that one, that is x power r equal to where e1 plus e2 plus e3 and so on, that is equal to r. We know that one, and n value we know whatever the power value has been given, that is going to be equal to n value, and we'll be finding out the coefficient of the given x power r. So now Now we'll be moving to the different type of problems. See, now here you will be having the find the coefficient of x power 20 in the equation x plus x square plus 2x cube plus x power 4 into x square plus x cube plus x power 4 and so on infinite series whole power 5. So what is this thing? It is going to be happen. So it is whole power 5 infinite series we are having. So we should make this series into the non-closed form equation. We should make the series as whatever the infinite series are there. So those things have to be converted into the non-closed form equations. If you know the closed form equations, then you can able to get the generating function for that one, and from the generating function you can able to get the what is that coefficient of the x power r. So they asked us to find out the what is the coefficient of x power 20 in x plus x square plus 2x cube plus x 2x cube plus x power 4 into x square plus x cube plus x power 4 and so on whole power 5. So for the infinite series. So now what I am by seeing this one, what we'll be doing simply just you think this one. So first one is the finite series, so there is no problem. X plus x square plus x square plus x power 4. So in that one, we will not having the x power 20 value. So while after multiplying with the second one only, we will be getting the x power 20 value. X power 20, the coefficient of x power 20 will be getting after multiplying the first term with the second term only. Okay, right. So while so you now we just kept aside the first term. Just you think about the second term. What are the things are there? In the second term, we'll be having x square plus x cube plus x power 4 and so on whole power 5. So if you do any operations on this one, you'll be getting the any known closed form sequences. Is it possible to us to get any closed form equation there? So yes, if you are going to be bring out the x square value outside, if you are going to bring out the x square value outside, then there is a chance of the thing which is known to us, which is the known series, which is going to become the known series for us. So what I'm going to do in a sense, I'm going to bring out the x square value outside. I'm going to bringing out the x square value outside, and what I'm doing in a sense, so then I'm going to converting the given function or the given series into the known closed form series. So when I'm going to bringing out automatically the power also coming outside. So x square whole power 5, I'm going to bring in outside. So then we'll be having the x square by default 1 plus x square plus and so on whole power 5. So then this 1 plus x square and so on whole power 5, we know the series of this one. So what is that 1 plus x square and so on infinite series, that can be replaced with the 1 minus x whole power minus 1. That can be replaced with the 1 minus x whole power minus 1. And this x power 2 whole power 5 is going to become x power 10. So now we know this one. So what is the thing is going to happen? X power 10 into x plus x square plus 2x cube plus x power 4 into 1 minus x whole power minus 5. So 1 minus x whole power minus 5. Right. So now this x power 10 is going to be multiplied with the first term, that is x power 10 into x, 10 plus 1 11, 2 plus 11 12, and 13 plus 10, sorry, 3 plus 10 13, 4 plus 10 14, like that x power 11 plus x power 12 plus 2 into x third x power 13 plus x power 14 into, now we are having the new term, that is 1 minus x whole power minus 5. So 1 minus x whole power minus 5. So 1 minus x whole power minus n, that is the finite sequence, but the generating function is going to become sigma r equal to 0 to infinity n plus r minus 1 cr into x power r. So this can be replaced with 1 minus x whole power minus 5 can be written with sigma r equal to 0 to infinity, sigma r equal to 0 to infinity, sigma r equal to 0 to infinity, that is r equal to 0 to 5, we can write this one as 5 plus r minus 1 cr, 5 plus r minus 1 cr into x power r. So then the value of r equal to 5. So the r equal to, we are now the r value you have to find out. So this can be written as 4 plus r cr into x power r, 4 plus r cr into x power r. So 5 minus 1 4, so it is going to become 4 plus r into cr. So now if this is the constant term and this is the variable which is the scope of the x, so this x is going to be multiplied with this x, whatever the x's are there here. So now it is going to become x plus x power 11 plus r plus x plus 12 plus r plus 2 into x power 13 plus r into 14, sorry, x power 14 plus r Now what is the thing we require? We require x power 20. So whatever the x power values are there, those values has to be equal to 20. So now I'm going to make 11 plus r equal to 20, 12 plus r equal to 20, 30 plus r equal to 20, and 14 plus r equal to 20. Then I will be getting the variables of r. That is r equal to 9, 7, 6, 7, 8, 9. So therefore for 4 terms we'll be getting 4 r values. Then this r is going to be implied in the this term. So that is the coefficient of these terms. So x power 11 plus r into sigma r equal to 0 to infinity 4 plus r cr. So r equal to 6. Then it is going to become 10 cr into x power 20. That is 14 plus 6. Then 11 plus r equal to 20. So r equal to 9. So this is going to become 13c9 into 13c9 into x power 20. This is going to become 12c8 into x power 20. This is going to become 11, 7 plus 4, 14, 11. So 11c r into, sorry, 11c7 into 4 to x power 20. Then last one is 6. So that is 20 x power 20. That is going to become 10 cr into x power 20. So now I am going to bring out the x power 20 for the coefficients. What are the coefficients are there for us? The first term is 13c9 plus second term is 12c9 plus 2 into 11c7 plus 10c6. So these are the coefficient of x power 20. These are the coefficient of x power 20. Like that we'll be finding out and we'll be implementing the, if it is a minus value, minus n is there, then we'll be converting that one into the sequence, that one into the generating function by using the formula sigma r equal to sigma r equal to 0 to infinity n plus r minus 1 cr n plus r minus 1 cr into x power r n plus 1 minus 1 cr into x power r. That formula is going to be used to get the generating function of the non-positive values of n. Non-positive values of n will be getting the sequence. We will be getting a generating function sigma r equal to 0 to infinity n plus r minus 1 cr. Just to have a glance on it. If you have any doubts, please ask me here. Just go through this one once again. Just to go through once. Just like these problems will be there for finding out. Sometimes they may ask this one directly for 10 marks also, man. So or 5 marks. Will be having the in the long answer questions. Will be having the 5 marks and 10 marks question. So directly sometimes they may ask it for the 10 marks, or they may ask it for at least 5 marks. Please go through this. Edma, is it clear? Is it clear? Anybody? Anybody having any doubts?
No, sir.
Edma. So we'll move to the next problem. So we'll be some more minutes to solve one more problem. So Sima, this one. So here we will be finding out the x for r value, the coefficient of x for r, by using the same series, that is the generating function for the non-positive values or negative values of n. So next thing is find the generating function that determines the number. No, see, okay, yeah, we'll see this one. This is a new type of problem for you. So you will be having the f1, f2, f3, f4, f5, xs. Then we are going to find out the f of x here. So now you see this one. So find the generating function that determines. Find the generating function that determines determines the number of non-negative integer solutions of the equation e1 plus e2 plus e3 plus e4 plus e5 equal to 20. So e1 plus e2 plus e3 plus e4 plus e5 equal to 20. That means that n equal to 5 and this solution equal to 20, that is r equal to 20 under the constraints that, so what are the constraints given for us is 0 is less than or equal to e1 is less than or equal to 3, then 0 is less than or equal to e2 is less than or equal to 4, then 2 is less than or equal to e3 is less than or equal to 6, and 2 is less than or equal to e4 equal less than or equal to 5, and e5 is the odd with the e5 is less than or equal to 9. That means that e5 value will be having the odd values and that is less than or equal to 9. So how you are going to, so you know the values of e1, e2, e3, e4. So e5, so e1 value which is 0, 1, 2, 3, u2 equal to 0, 1, 2, 3, 4. Coming to e3 will be having 2, 3, 4, 5, 6, and e4 will be having a 2, 3, 4, 5, and e5 is odd value with less than or equal to 9. That is, what are the odd values less than 9 will be having? Less than or equal to 1, 3, 5, 7, 1, 3, 5, 7, 9. So these are the values are there. So now we know this one. That means that what the values, you know, we know that one a power 1 1. So f of x we said that one. So even నుంచి మనకి will be getting the f1 of x, that is a power 1 1 plus a power 1 2 plus a power 1 3 plus a power 1 4 plus a power 1 5 and so on. F2 of x equal to a power 2 1 plus a power 2 2 plus a power 2 3 and so on. F3 of x equal to a power 3 1 plus a power 3 2 and so on. Then f4 of x equal to a power 4 1 plus 4 2 plus and so on. Like that we'll be having the things. So now we know that when e1 equal to 0, so ఏమన్నా ఇక్కడ 0 is less than or equal to e1 is less than or equal to 3. That means that ఏమేమంటే మనకి 0 equal to then 1 then 2 then 3. So this is going to become e1 కాబట్టి a11 then a12 then a13 then we'll be having a14. That is, so f1 of x, how can you write f of x? F1 of x can be written as x power a11, that is x power 0 plus x power 1 plus x power 2 plus x power 3. See like this. X power 0 plus x power 1 plus x power 2 plus x power 3. Then u2 will be having the values up to 4. So f2 of x can be written as x power 0 plus 1 plus 2 plus 3 plus 4. Then f3 of x equal to, so ఏమన్నా ఇక్కడ 2 is less than or equal to 3, e3 is less than or equal to 6, that is 2 3 4 5 6. So 2 3 4 5 6 is for f3 of x, and for f4 2 3 4 5 only, so that is 2 3 4 5. Then f of I will be having odd values of less than 9, that is 1 3 5 7 9. So these are the things we are having for the f1 of x, f2 of x, f3 of x, f4 of x. Now they ask you find out what is the f of x. So the generating function f of x can be written as f1 of x into f2 of x into f3 of x into f4 of x into f5 of x. So we'll be writing what is that f1 of x, 1 plus x plus x square plus x cube. Then what is the f2 of x, n plus x plus x square plus x cube plus x power 4. Then f3 of x, x square plus x cube plus x power 4 plus x power 5 plus x power 6 into f4 of x, x square plus x cube plus x power 4 plus x power 5, and f5 of x we are having x plus x cube plus x power 5 plus x power 7 plus x power 9. Then we are going to be multiply all these things, we'll be getting the generating function. So this one plus x plus x square plus x cube, that is, this is a finite series. So we said that 1 plus x plus x square plus and so on x power n, then written as 1 minus x power n plus 1 by 1 minus x. 1 minus x power n plus 1, that is 3 plus 1 by 1 minus x, that is 1 minus x power 4 by 1 minus x. Same thing here also we are going to multiply here, apply, then we'll be having 1 minus x power 5 by 1 minus x. So coming to the next one, here I am going to common x square outside, then we'll be having 1 plus x square plus x cube plus x power 4. So I can write this one as x square into x power 4 is the topmost n value. So 1 minus x power 5 by 1 minus x. Same thing in this one also, I am going to take the common of x square. I'll be getting 1 plus x plus x square plus x cube. So this can be written as 1 minus x power 4 by 1 minus x. Then this is, I am going to take the x as a common first. Then we'll be having 1 plus x square plus x square plus x cube. Sorry, 1 plus x square plus x cube plus x kada first this is 1 plus x square plus x power 4 plus x power 6 plus x power 9, that is exponent x power 8. These are things we'll be having. So now I'm going to multiply 1 minus x whole power 4 into 1 minus x whole power 4. So this is going to become 1 minus x power 4 whole square. Then 1 minus x power 5 into 1 minus x power 5. So 1 minus x power 5 square. Then x square into x square into x power 5 first. So these three are the on the top. What all the things are there on the numerator? Those things are first done. So in the down will be having 1 minus x into 1 minus x into 1 minus x into 1 minus x. So this can be written as 1 minus x whole power 4. So if we are going to bring this denominator into numerator, then we are going to become 1 minus x whole power minus 4 first one. So up to this one, okay. Now I am going to do the operation on this one. So what is the thing is there? 1 plus x cube plus x power 4 plus x power 6 plus x power 8. So what I am going to do in the same, I am going to do in the place of x, x square. So in the place of x, x square, then it is going to become 1 plus x square whole power 1 plus 1 plus x square whole square plus 1 plus x square whole cube plus x square whole power 4. So now will be it is there in the form of 1 plus x square plus x cube plus x power 4. So this can be written as 1 plus x whole power the 4 కాబట్టి 5 1 minus x power 5 by 1 minus x. So here the place of x will be behind x square. So we are going to write 1 minus x square 4 power 5 by 1 minus x square. Then we will be getting the series. This 1 minus x square can be written as 1 plus x into 1 minus x. So this 1 minus x is going to become top, then it is going to become minus 5. Then 1 plus x whole power minus 1 into 1 minus x power 10, that is x square power whole power 5, that is 10. So like this we will be finding the f of x value by using the f1 of x into f2 of x into f3 of x and so on. So like this, right now. So yeah, please give your names in the chat box. We'll discuss the rest of all the problems in the next class. Yes, make it fast. Your names in the chat box.
సార్
చెప్పరా
సార్ ఇన్ఫోర్ సార్ నాకు ఇక్కడ టైపింగ్ చేయడానికి వస్తలేదు సార్.
ఓకే అమ్మా రైట్ N4. ఓకే
ఎస్ సార్.
ఓకే రైట్ తీసుకున్నాను.
థ్యాంక్ యూ సార్.
ఓకే రైట్.